Hello everyone, welcome to this video on machine learning. Now in this particular video we will be talking about a very important machine learning algorithm, that is k nearest neighbor. In short we call it as KNN. Now k nearest neighbors or KNN we will try to explore and we'll try to see with a real life example of classifying different flower species using this particular machine learning algorithm. So first let's try to understand what exactly is k nearest neighbor. Okay, now there is one parameter, one variable that we need to look into, and that we will find using some methods, using some algorithms, something like elbow method or different algorithms are there that we try to work upon and find out this variable k. Otherwise, the KNN algorithm is a machine learning algorithm, is a supervised machine learning algorithm that is non-parametric, okay, and that is generally used for classification and sometimes for the regression task as well. So that is what the KNN algorithm is, and there is a variable that is k, and we have certain methods, certain algorithms like elbow method is one of the popular methods to find out the value of k. Okay, there are experimental methods as well to find out the value of k as well. So this is what exactly the KNN algorithm is. Now how does the KNN algorithm works? Let's try to see. Let's say we have the classification problem where we have two variables x1 and x2. Okay, and each of these there are two different types of data. One is in the square shape, another is in the triangle shape. Now there is an unknown circle that you can see in the red, that is in the middle. Okay, now what we need to do is we need to find out we need to classify this particular circle, okay, into one of these classes, either class A or class B. Now how do we classify this particular circle, this particular unknown data point into them, is what the challenge is. Okay, and that is what we will try to solve using our algorithm of KNN. Okay, so what we do is we just calculate the distance. Okay, we just calculate the k nearest neighbors from this unknown point, from this unknown data point. Okay, and how do we calculate this distance? Another topic of discussion, we will have it. Okay, what is the value of k? We have talked about that. And how do we what do we do once we have got the k nearest neighbors? Let's say in this you can see a small circle that is been drawn here. The final circle or the final nearest neighbors, okay, let's say the value of k is 7, so it means that we need to identify 7 nearest neighbors to this unknown data point, and that's what we have selected. Okay, so 4 are coming as triangle and 3 are coming as square boxes, right? Correct, that is what we can see from the circle. Now when this is the ratio that we are getting, when this is the output that we are getting, what we will do is we will assign the unknown data point or the test data point that we need to find out, that we need to classify into the majority class. Okay, the majority class is class B. Okay, class B, or you can say the triangle. So it means that the unknown data point that is represented with the red circle in the start will be classified as triangle, will be classified as class B. So this data point will belong to class B. That is ultimately the total algorithm. Now what we are going to talk about forward is the calculation, is about the data set that we are going to take in and understand, and the intuition that we will try to develop about a particular algorithm, about the KNN algorithm, about this particular data set problem solving. Okay, now this is the data set that we have. We have sepal length, we have sepal width, we have petal length, we have petal width, and we have the species. Okay, so this is what we need to predict. This is what we require. This is our dependent variable. Okay, dependent variable, and this is these all are the independent variable that will be used to classify any flower species into these classes. Okay, so iris setosa is one class, versicolor is another class, there is another class that is virginica. Okay, so these are the 3 classes that we try to identify each flower species based on their values in these 4 variables. Okay, in these 4 attributes, in these 4 independent variables. Now what we will do is, this is what the data set looks like. Okay, first thing, Second thing, how do we calculate the nearest neighbors? Okay, what is the distance? How do we calculate the distance between two data points? Okay, so there are different methods of calculation of distance between two data points in the Cartesian plane. Okay, two of most commonly used distance matrix that we will use. Let's say these are the 2 points we have, x1 y1 and x2 y2. These are the two data points. We need to calculate this distance d between them. So the formula that we use is this. Okay, this is the formula. We will put x1 minus y1 square plus x2 minus y2 square. So yeah, differentiate, like take the difference between them, summation, we square them, and we calculate the Euclidean distance. That's the very standard formula of calculating the Euclidean distance. Okay, of calculating the distance between two data points in a Cartesian system. Another approach or another method that you can use to calculate the distance between two unknown points, two coordinates, okay, is the Manhattan distance, or you can also call it as L1 distance. Okay, and this is the formula for doing that. This is nothing but modulus. Okay, here what we were doing, we were just squaring first, and then we were taking the under root. Here what we have done, we have removed the square, we have removed the under root, we are just taking the modulus value of the difference between them. Okay, so these are the two most commonly used methods of calculating the distance. Okay, and you can use any of these methods for calculating the distance and get the nearest neighbors. Okay, k nearest neighbors from the unknown data point that we need to classify. Okay, so that would be our challenge, and these are the distance methods that we will use and we can use to calculate the nearest neighbors. Now let's talk about the working. Okay, let's try to understand the intuition from the data set that we have to consider, the iris data set, our own data set iris, and try to understand the situation here. So see, let's say on the x-axis I have the sepal length, and on the y-axis I have the sepal width. Okay, so these are the two variables I'm considering, and I'm plotting all the data points using these two and comparing these two variables, and I'm classifying each flower species into one of these three classes: Setosa, versicolor, and virginica. Now what will happen, so each of them has been classified. You can see each of the data points belong to either red or blue or green color crosses, right? Let's say we have a cross. Okay, let me change the color of my pen. Okay, let's say we have a black color cross here. Okay, now this is an unknown data point. Okay, I need to classify this particular data point, and this may be the value of sepal width that this data point has. This may be the value of its sepal length. Okay, so you know the values of sepal length, you know the values of sepal width, you would be easily able to classify this. Okay, now how we are going to classify this using the KNN algorithm, you already know the working of it. So what we will do, let's say the value of k comes out to be 5, so we will select five nearest data points that are near to this particular unknown data. Okay, let's try to identify 5 nearest points. So let's say one of this nearest point is this, another is this, another is this, another is this, another is this. 1 2 3 4 5. Okay, let's say these are the 5 nearest data points that I have got. Okay, now if I try to see what is the result that I have got, so in total 1 2 3 4, there are 4 blue crosses of 4 blue points, 4 nearest data points that are of color blue, and 1 is of the color green, and 0 of the color red. Okay, so it means on the majority side the blue is leading. It means that the unknown data point that I need to classify, that is this black cross, will belong to versicolor, will be actually a blue cross, would actually be a blue cross. Okay, so that's how the KNN algorithm working is. Okay, and it's a very intuitive, it's a very you can say easy algorithm to understand. Its intuition, its maths, and its working behind. Okay, so I hope you have got a good idea about how exactly the KNN algorithm works and how we can implement it on the iris data set, and you must have got the intuition behind it. So thank you very much for watching this video, and these are some of the social media links that you can follow us on. And again, thank you, and I hope to see you in the next one.